Bismillahirrahmanirrahim. In the previous discussion, we had started chapter 12 of your book, analysis of variance we discussed. And in previous class, we discussed analysis of variance, where we considered treatments. And we said that in the null hypothesis, the means for the treatments are equal, and then alternatively we said that they are not equal. So we basically solved this example in previous class, if you recall your memory. This was the second application of F statistic, and in this we solved this example where banking, retail and insurance industries were there, and we solved this example in 6 steps. And I also used 2 methods to find out the calculated value for F statistic. One is similar as it is there in your book, and the other one was this method. You can see it in this table. And from this we found F statistic, ultimately this value. So you are familiar with all this procedure, so there is no need of describing it again. So today I am interested in, first of all, looking an example where I would have unequal values in the treatments, because if you see the previous question that we had solved, there were equal values in all treatments, but here you can see different values are there in different treatments. So how can we solve the question of this form? So let us see. This is the example. The same example is there in your book. I have simply changed the names. So you can see this example. This is exactly this example is there in your book. Recently, airlines cut services such as meals and snacks during flights and started charging for checked luggage. A group of 4 carriers hired Brunner Marketing Research Incorporation to survey passengers regarding their level of satisfaction with a recent flight. The survey included questions on ticketing, boarding, in-flight service, baggage handling, pilot communication, and so forth. 25 questions offered a range of possible answers: excellent, good, fair, or poor. A response of excellent was given a score of 4, good a 3, fair a 2, and poor a 1. These responses were then totaled. So the total score was an indication of the satisfaction with the flight. The greater the score, the higher the level of satisfaction with the service. The highest possible score was 100. Brunner randomly selected and surveyed passengers from the four airlines. Below is the sample information. Is there a difference in the mean satisfaction level among the 4 airlines? Use 0.01 significance level. So the same question is there that I have written over here in the PowerPoint slide. You can see I have not given the names that are there in your book. I have simply changed the airlines. Let's say American Airline, Canadian, Air Canada, China Airline, and Air France, let's say. So instead of writing these names, Northern, WTA, Okono, and Branson, I have changed the names. However, data are same. There is no change in data. So how will you start solving this? Basically, let's say, what is this 94? This is the satisfaction level that this value you have obtained on having the answers or against the questions that you asked, and for each question there was some answer in form of excellent, good, fair, or poor. So you added those codes and finally you obtained this value. So for 25 questions, when you added the codes that were given to the questions, you obtained these values. So these values are there. So the question is this, is there a difference in mean satisfaction level? So you can see that when you will add these values, and you will find out the means. So whether those means are equal or not. So definitely this is the sample data, and whatever you want to say something about population. So in case of population, only these values will not be there. There will be so many values. You have selected few, you can say, uh, passengers to whom you interviewed. But in fact, there are not few passengers, there are so many passengers. But basically, you are interested in knowing that whether the mean satisfaction level of these four airlines are equal or not. So if they are equal, let's say, then you may reserve your seat in any airline, okay? And you will feel the same satisfaction level. Otherwise, if you see the satisfaction levels are different, so then it's upon you that which airline you will prefer. So if you have money in your pocket, definitely you will go for a better airline where you would have better facilities. So this is the case. So before deciding reserving a seat, it would be a better decision to check that which is a good, you can say a better airline comparatively regarding the facilities. So for this, you can see the scenario is, I think, clear. How will you start solving this? First of all, you will write down null and alternate hypothesis. And here I have written mu AA, mu AC, and mu sub CI, mu sub AF. What this means, these are the averages, or you can say the mean satisfaction level or average satisfaction level from different airlines that passengers obtain. So you can see this is your null hypothesis, and in the alternate hypothesis, you will write down there is a significant difference in mean satisfaction level of passengers among four airlines. So if you see the null hypothesis, there is no difference, and if you see the alternate hypothesis, you may write down all means are not equal, or you can say there is a significant difference in mean satisfaction level of passengers among these four airlines. Then you will write down in second step level of significance, that is written over here, 0.01. You can see in your book it is 0.01. Same. Test statistic. The test statistic follows the F distribution, because why it is F distribution? Because there are more than two populations. So up to two populations, we normally use Z or T. And when the populations are more than two, three or more, then we take help of F distribution. So the formula for F distribution is this. This is the mean square, you can say, for between sum of square, and this is the mean square for error. So this you may write it down as SB square over SE square that we had done in the previous example. So your target is that you have to find out these two values. Then there comes decision rule. This is the fourth step. And for this problem, there are four treatments. Treatments means there are four airlines. So four airlines are basically the four treatments. And a total of 22 observations. So when you will add these values, you can say count these values 1, 2, 3, 4. So in total, they will be 22. Degrees of freedom for numerator, you simply subtract 1 from the number of treatments. So treatments are 4, 4 minus 1. The degree of freedom for numerator is 3. Degree of freedom in the denominator, total number of observations, these are 22, and you have to subtract K, that is the number of treatments, those are 4, so the answer is 18. So you have to see the F value, F statistic, tabulated value of F, or you can say the critical value in this case will be the value that you will find out against 3 degree of freedom for numerator and 18 degree of freedom for denominator. So you can see it from the table, and the table will be of 0.01 significance level. So from that you can see I have already calculated this. I have already seen this value and written here for you F01. F01 means at 1% level of significance. 3 new, this is the new 1 value, this is new 2 value. So this is 3. Degree of freedom for numerator, degree of freedom for denominator is 18. So you can see that it is 5.09. You can see it from the table 3 and 18. I have highlighted this. You can see these arrows are indicating this value against 18 and 3. This is 5.09, and you can see this is the table available in your book, and you can see 0.01 is the significance level. There is another table. There are basically two tables available in your book. One is for 0.01, that is 1% level of significance, and the other is 0.05, so that is 5% level of significance. And in previous class I had given you few tables of F statistic where we have other levels of significances also. So you can take help of any table for finding the critical value. So this is your critical value, and in decision rule you write down if F statistic calculated will exceed the tabulated F statistic, we would reject as not. So this is the rule that we normally follow. Now you have to find out some values that will help you in finding out the calculated value of F, because tabulated value is there. Now the target is to find out the calculated value. So calculated value is you can say is not an easy task. You have to engage some calculations. So here you can see AA means American Airlines. So I have written simply the values 94, 90, 85, 80, whatever values were there in the example, like this in tabulated form. So what you will do, you will simply take square of this value 94. Square of 94 is this, and you will write down this value in the braces. And similarly for other values, for all those values that are there in the example, you will take square of each value and write down that squared value in braces. And here you can see this is summation jxi j square. So what this means, summation j, in j means columns. So whatever written in the column, you have to add those values. So xij square, squared value, it means whatever value is there in the braces, you have to add those values. So 8836 plus 5625 plus 4900 plus 4624, the answer is this. Similarly, all those values that are there in the columns, you have to add those values to have this column. Right? Similarly, you have to find out T dot J. T dot J means you have to add the values that are there in the rows. So dot is an indication for row. So because rows are different, row 1, row 2, row 3, row 4. So therefore, Tij, basically Tij will be, J will remain constant, the first column, and row will change every time. So the first value, this value will be called, you can say that position of this value is T11. T11 means the first row and the first column. So this value will be there. Similarly, what will be the address for this value? The address of this value, you can say, will be T21, T sub 21. That means second row and the first column. So this value is there. Similarly, T31, T4 sub T sub 41. So that will mean fourth row and the first column. So you will add these values, 94 plus 90 plus 85 plus 80. The answer is this. Similarly, these values. So you will obtain this row. That is simply the sum of these values that are there in the columns. And then you will simply take square of this value. Square of this value will be written over here. That is T dot J square. Similarly, you have to square all these four values. So 414 square, the value is 171396. Similarly, other values. And now finally, this is summation ixij square. So I again is for rows. So now you have to add the rows. And in rows, you have to add those values that are there in the braces, as you have done over here. J, where you added the columns and you added those values there, those were in the braces. So now you have to add the values that are there in the braces, but written in the rows. So first row, second row, third row, fourth row. So yeah, you have to add these four values, and you will write down this answer over here. Right? Similarly for others. So finally, you will add these values and you will see that what is the answer, what is the total for these values. So it is 127344. You can check it. And when you will add these values, again you will have the same answer, because in total, whatever you will find out the answer for the values that are there in the braces, that should equal whether you are going to add the rows, whether you are going to add the columns. But this value will help you in knowing that whatever you have calculated, that is correct and you are in the right direction. So therefore you have to check this value. This value should match this value. And then you have to add these values 349, 391, 510, and 414 to have this value. This is basically the value that you can say is the sum of all those observations that are there in the data. So sum of all observations that is there in the example. So it is 1664. So this value is also called T dot dot, total of all observations that are there in the given example or question. So this is T dot dot, and you have to find out the correction factor with the help of this value that you will subtract from the uh, some particular term to find out the sum of square, you can say, for between treatments and sum of square for within treatments. So let us see how we will find out this. In previous example, we also found this, but here in this question, a minute difference in the formula will be there. So let us see. You have to take square of T dot dot. So T dot dot is 1664. You have to take square of this value and you have to divide it with the total number of observations. Those were 22. So this is the answer. This is your correction factor, and this will be subtracted from these terms. So what will be total sum of square? Total sum of square means total variation in the data. So you have to write down this value that you have checked, 127344, 127344. So you have to write down this value over here, and then you will subtract correction factor from this. The answer is this. And then you are interested in finding out the between sum of square, or you can say the sum of square between treatments. Sum of square between treatments. So B is for between. So there are four treatments. So initially, if you see the previous example, there we simply wrote T dot J divided by R. There were only four, you can say, rows. But in this case, you can see rows are different. For each treatment, the rows are different. For the first treatment, 1, 2, 3, 4, 4 rows are there. For second treatment, 5 rows are there. For third and fourth treatments, different number of rows are there. So therefore, in the previous example, if you recall your memory, we were writing this formula. If you see, simply I wrote R. Why R? Because there were 4 rows. So you can say 4 were common, a common value. So basically, against each value of T dot J square, I mean this value. So this value divided by 4, this value divided by 4, this value divided by 4. And you can take 1 over 4 as common. So no problem. You can find out the value that is required in the formula, this value. Right. So, but in this case, if you see, as number of rows are different, so what will we do? We will use this value, T dot J square, divided by the number of rows that are there here. Here, 1, 2, 3, 4. Okay. So you will divide this with 4. Similarly, the second value is this 152881, and you have to divide it with 5. Why 5? Because there are 5 rows. Okay, so as we cannot take common, these values could not be taken as common. In the previous example, 4 was common in all terms, so we took 1 over 4 as common. But in this case, you can see we cannot take common, any value as common. So therefore, we are writing the number of rows for each t dot j square. Okay. So when you will solve it and subtracting the correction factor from these all these terms, so you have to take care of these braces, big braces. Okay. And first of all, you will solve these four terms, and then whatever will be the answer, this correction factor will be subtracted from that to have this answer. So this is your between sum of square, this value. And you know, total variation or total sum of square is equal to between treatments variation and the error sum of square, or within, you can say, within treatments, the variation within the treatments. So between treatments and within the treatments. So for between treatments, we write down BSS, and for within treatments, where we take care of all observations, we write down error sum of square or within sum of square. So here you can see TSS, we have found this value, and we have already found BSS. So now by taking help of, with the help of this formula, we can find out ESS. So the value for ESS may be found if you transform this formula in this way. ESS is equal to TSS minus BSS. So the answer is 594.407. So this is the total variation, total sum of square. So now you will write down an ANOVA table. So in the ANOVA table, you will be able showing the F statistic in form of, you can say, a ratio that will be in the here. So let us see how will you construct the ANOVA table. First of all, these columns are fixed: source of variation, degree of freedom, sum of square, mean square, and finally computed value of F. So between groups or between treatments, that is B. So between treatments, B, and degree of freedom in that case, because 4 treatments were there, -1, 3 is the answer, 3 degree of freedom. And if you see within groups, total observations 22. You have to subtract K, number of treatments, from the total observations, that is 4. So 22 minus 4, the answer is 18. And then total sum of square will be n minus 1, total observations -1, that is 21. So you can see 21 minus 3 is equal to 18. So if you simply write down between groups, number of degree of freedom 3 and total 21, then you can straightforwardly write down the degree of freedom for within groups by subtracting 3 from 21, or otherwise you can use these formula K minus 1, n minus K, and n minus 1. And then SB square, this value we have already found. SB square, this is the between sum of square value, and we have found it over here. If you see 890.59, so you have to use this value over here. Simply write down this value. In the next row, you have to write down the error sum of square, and that is also denoted by SE square, or you can write it down as ESS. So the value for that is this, that we have found using this formula, 594.407. And then total variation, we have already found. So this is the value, total variation. You can see from here, 1485. This is that value, 1484.997. Right. So now you can see we are basically interested in finding out MSB and MSE. So mean square between treatments and mean square error. So mean square error is the denominator, and MSB, mean square between treatments, is the numerator. So to find out this MSB and MSE, what you have to do, you have to divide degree of freedom of SSB or BSS with this value, SB square or BSS, this is, and divide by 3. So by dividing it by 3, you will have 296.86. So this is your MSB, and similarly SE square will be this value, 594 divided by 18. So this is the answer. And for F value, you have to divide this value with this value, as I have done. So you will obtain 8.99. So you can see the calculated of value for F statistic is 8.99 that we have found. And now you have to compare this value with the critical value that you found using the table. So that was 5.5. 09, 5.09. So you can see the calculated value is larger as compared to the critical value. So what will you do? You will simply say that we are going to reject H naught. So rejection of H naught is there. Since this is the case, so there is a difference in the mean satisfaction level of passengers among four airlines at zero point zero 0.01 significance level. So the result is that the satisfaction level is not same, as we are going to reject the null hypothesis. So rejection of null hypothesis means the satisfaction level is not same. Fine. Are you with me?
Yes, sir.
Yes,
Today I
sir.
am feeling a problem in speaking because I have pain in my throat. So I think you are able to listen me, but there is some difficulty in speaking.
Yes,
Okay.
sir. We are listening, sir.
Okay, sir.
Okay. So now come to the previous example that we did yesterday. Yes. So once you see that you are going to reject H naught, on rejecting H naught, you will definitely accept H1. It means that all means are not equal. So as in this case, you can see that satisfaction levels are not equal. So different satisfaction levels are there. Okay. So if you see the previous example that we solved in previous class, where we took into account the banking, retail, and insurance industries, and we finally said that we are going to reject H naught. So rejection was there also. So now on rejection, you can see uh, the null hypothesis. In that case, this was the null hypothesis: mu b is equal to mu r is equal to mu I. So you have rejected this. The rejection of this means uh, exception of the alternate hypothesis. Exception of the alternate hypothesis, that is, all means are not equal. So now you will check one by one. You will check one by one, and you will confirm that which two means are not equal. In fact, which two means are not equal. So how will you check this? And definitely in today's example, when you will see it for four different values. So let me explain it over here. What I want to say, I want to say this. Sorry. Basically, you are saying that H naught and H1, these are there. So mu1 is equal to mu2 is equal to mu3. Let's say this is the scenario, and in the alternate hypothesis, you are saying that all means are not equal. All means are not equal. All means are not equal. What this means, if you are going to reject H naught, null hypothesis, all means are not equal, you are going to accept this statement. So all means are not equal. There are three means. So you will say mu1 is equal to mu2. No, this is not the case. The second possibility may be mu1 is equal to mu3. You say no, they are not equal. This is also possible. Another possibility is that mu2 is equal to mu3. You say no. Okay. So at least one pair is such that is not equal, in which the averages are not equal, at least one. So it is quite possible that two are equal and the third one is not equal. Okay. And because of that third pair, you are going to reject H naught because of that. So you have to check that which two pairs are not equal, in fact. And for that, you have to take help of uh, this formula. I mean, this formula. Sorry, let me see. This formula: x1 bar minus x2 bar plus minus t. T is the t statistic. This will be the critical value, and MSE, mean square error, that you will see from the ANOVA table. Okay, and N1 is the number of observations in the first treatment, number of observations in the second treatment. So let us see that how will we use this formula. X1, what X1 means? Mean of the first sample. So in this case, mean for the first treatment, mean for the first treatment, and mean for the second treatment or second sample. So these were the two samples you can see. In this case, banking and retail. And in today's case, American airline and the, uh, you can say Air Canada or whatever airline was there. So one treatment, so what will you do? X1 bar you have to find out. So you will add these values. On adding, you will have 54. 54 divided by 1, 2, 3, 4, 5. 54 divided by 5. So you will find out the X1 bar. Similarly, X2 bar, 40 divided by 5. So you can see X1 bar, whatever will be the value, you will find out, you will subtract X2 bar from that, as I have done over here in this formula. What is T statistic? Against degree of freedom, that is the total number of observations minus the degree of freedom, minus the number of treatments. So in this case, 4 treatments are there, total observations are 20. I think in this case it was, total observations were 1, 2, 3, 4, 5, 1, 2, 3, so 15. 15 were the total observations, so you have to subtract 3 from that to have the degree of freedom. That degree of freedom will be used in the T statistic table. Okay, and similarly N1 and N2 I have explained that these are the number of observations in the treatments. So what situations may be there? There may be 3 situations that I have written over here. These 3 possibilities will be there. So instead of 1, 2, 3, he is writing banking, retail, and uh, the third industry, that was insurance industry. So first possibility, that banking and retail, the averages for these 2 industries are same. Alternate will be they are not same. Banking and insurance equal? No, they are not equal. Retail and insurance, the means in these 2 industries are equal. The average for these 2 industries are equal. No, they are not equal. So these are the total 3 possibilities. And if you are going to see the today's example, let's say in this case, there will be 4 uh, possibilities: mu1, mu2. Let's say mu1 is for Air America, mu2 is for Air France and Air Canada, so, and China Air. So let's say mu4 is for China Air, and mu3 is for Air France, and mu2 for Air Canada, and mu1 for Air America. So you can write down A, C, C, I like this. So it's a fun. But how will you construct the null and alternate hypothesis when you are going to reject this scenario? It means when this is H naught and you have rejected this, so it means that at least one pair is not equal. Okay, sorry, you will put colon over here, colon. Okay, so there may be a situation mu1 is not equal to mu2. Another possibility is mu1 is not equal to mu3. Another possibility, mu1 is not equal to mu4. Okay, so these are the possibilities. So you will check one by one, or otherwise mu2 is not equal to mu3. Mu2 is not equal to mu4, or mu3 is not equal to mu4. So these are the total possibilities that you will check in this case, that is there in front of you, and we have solved it. But as I have solved these 3 for the banking, retail, and insurance industries case, so we take help of these hypotheses to confirm that how will we find out that whether they are equal or not. And I mean, what will we do regarding the rejection or exception of the null hypothesis in these 3 cases. So let us consider first case where H naught, the null hypothesis, is average of banking industry and average of retail industry. So banking industry, so what will you do? You will simply add these values that are there in this column. these values. Mean number of hours spent per week by industry. So in banking industry, number of hours spent are these. So you will add these values and you will divide these values with 5. What is this 5? Total number of observations. So in this way, you will find out an average, and that average will be the average of uh, average of banking industry. Okay. Similarly, in retail, these were the values, so divided with 5, so the answer is 8. So now these are the two values that you will substitute over here in this formula, x1 bar minus x2 bar. Now you are interested in finding out critical value for t statistic. So for that you will use degree of freedom, that is 22, and you will see it against point. In this case, what was the level of significance? You will see that level of significance. The level of significance was given in the question. I think it was 0.05. So against 0.05, you will see that what is the value of t statistic over here. So you can check it. The answer will be this value, 2.179. So you are familiar with t statistic table, so there is no need of opening that table over here. You can check this value from the table against 22 degree of freedom. Fine. And then comes MSE, mean square error. Mean square error is there in the ANOVA table. This value is there, mean square error 2. So you will utilize this value 2. And in today's question, definitely you will use this value, mean square error, if you are interested in finding out the equality or inequality between the pairs. So you will use this 2 over here in this formula, and 1 over n1 and 1 over n2, these are the number of observations in the treatments. So 1 by 5, 5 values are there. You will solve it. The answer is this. Because positive and negative sign is there, so once you will add and once you will subtract. So on subtraction, you will have this value 0.85, and on addition, you will have this value. Now see, how will you decide about the rejection or exception? So you can see from here, as 0 does not fall in this interval, therefore we can conclude that there is significant difference in the selected treatment means, that is banking and retail. So you have to see that whatever range you will find out, whether value z is there, value 0 is there in that range or not. So let's say it was minus 0.85. Let's say it was minus 0.85. So from minus 0.85 up to positive 0.474, 0 were there in the interval. So you will say that as 0 is there, so there is no significant difference. As 0 is there in the interval, there is no significant difference. But if you see this interval, there is no negative sign, because you can see this is a positive value and this is also a positive value. So 0 will be less than 0.85. It means that 0 is not there in this range, in this interval. Therefore, you will say that as 0 does not fall in this interval, therefore we can conclude that there is a significant difference. Significant difference means these two are not equal. As these two are, I mean, if 0 is not there, you will reject this, the null hypothesis. If 0 is not there in the interval, you will reject the null hypothesis. And rejection of null hypothesis means there is difference. There is significant difference between the two industries. Understand? So you have to see that whether the 0 is there in the interval or not. So I have, you can see this from here, 0.05 against 0.05, and degree of freedom 22 minus number of treatments 3, 19 degree of freedom. This was the value, n minus k. N was 22, total number of observations. Sorry, let me check what was the total number of observations. In this case, 1, 2, 3, 1, 5. 5 multiplied by 3, 15. So this is on something else. Don't consider this table. Uh, don't consider this table. You have to see it because you can see 1.729 is there and I'm writing 2.179. So 2.179 is the degree of freedom, that is 15 minus 3. There were total observations. How many observations are there? 15 minus 3, 12. Let's see what is there against 12. See, 12, 2.179. This is the value basically. Against 12, 2.179. Okay. It was two-tailed. So therefore, against 0.05, 2.179 is the value. So 15 minus 3. 15 is the total number of observations. Minus 3. 3 is the number of treatments. So three treatments are there. So you will consider this value. I have simply copied this table from somewhere else where I use this value. So therefore arrows are there. So don't consider these arrows. Basically, this is the value 2.179 that I have used over here. So similarly, when you will consider this situation, the other situation of airlines, in that case, what will be the degree of freedom that you will use in T distribution? That will be total observations are 22. 22 minus 4, 18. So against 18, you will check what is the T statistic. Okay, so simply finally you have to see that whether 0 is there in the range that you will find out or not. If 0 is there, accept as not. If 0 is not there, reject as not. So as 0 is not here in this case, so we are rejecting the null hypothesis and we are accepting the alternate hypothesis. So in this way, you will also check the other averages. Let's say the other was mu b is equal to mu I. So you will see mu b is not equal to mu I. The second case will be there. And for those, you will again add the values that will be there in the treatments and divide with the total number of observations, and you will find out x b bar and x I bar, and then you will use this formula to find out the interval, and finally you decide that whether those are equal or not. And similarly in third case, and in this situation you will check one by one for all these. So 1 2 3 4 5 6 6 situations will be there. So for all these 6 situations, one by one you will check and you will see that whether which means are not equal and which are equal. So in case you are going to accept the null hypothesis, in that case means will be equal, and when you will reject as not, you will say that means are not equal. So this is the story that you will use in F statistic when you see there are 3 or more populations are there in picture. So thank you very much for your patience. This is all for today, and in the next class we will inshallah consider two-way analysis of variance.
Inshallah,
So
sir.
that will be our next topic. This topic we will see later on in next class inshallah on Friday. So till then, if you have any question, you may ask now, and if you don't have any question, then try solving the examples in the book and see whether you have learned things or not. Is there any question?
No,
Sir,
sir.
Okay, thank you very much.